Hi everyone, welcome to my channel STB Academy. Today we are going to discuss about current electricity. So class 12, current electricity class 12, IIT-JEE Neet topic. At the same time, that is there in the grade 10 CBSE physics topic. So you can see what are the topics we are discussing in this video. One is electric current, drift velocity and Ohm's law. These are the three topics we are going to discuss today class. First of all, electric current. So what is electric current? Normally you see in a conductor when you on the switch, so when you connect the battery, so I'm considering here like I'm considering like this. So this is a conductor I am considering. So that will be connected to the battery. So you can consider here it is the battery. Switch I am considering. So like this. So positive terminal, negative terminal, conductor like this. You can take electrical wires. So these are the electrical wires also you can consider. So positive terminal, a negative terminal I am considering. So like it's like a resistor also we can consider. Here it will be resistor. I'm considering here like a bulb or anything you can take. So how the electric current is passing inside of the wire? How the electric current is passing inside of the wire? So normally you see uh, the in the inside of the battery, what happens? Normally you can consider. So this is a battery. You can consider this battery like a number of one or two more cells will be added. This is a battery positive terminal and this is the battery negative terminal I am considering here, right? This is a negative terminal here, this is a negative terminal. The electrons are moving from negative terminal to positive terminal, right? So negative terminal to positive terminal. So like this, here it is moving, okay, like this. Even you can consider inside of the conductor, inside of the conductor, the electrons are moving like this. Electrons are moving from negative terminal to positive terminal inside of the conductor, like electrical wires also. Electrical wires you can consider electrical wires. So electrons, negative, elect, negative charge. Electrons are moving from negative terminal to positive terminal. But for our conventional, for our convention, because so many theorems already so made on this statement, that is, so the flow of positive charges, the flow of positive charges that will be considered electric current. So like the charges are moving from positive terminal to negative terminal. The charges moving from positive terminal to negative terminal, that will be considered as current. That will be considered as a current. That is a conventional current. But actually the electrons are moving from negative terminal to positive terminal. Negative terminal to positive terminal. So even in the problem also, if they ask, so the electron beam is moving like this. Electron beaming like so negative terminal. That is nothing but electrons are moving. So we can take the direction of the current opposite to the electrons flow. Opposite to the electrons flow. Okay. So that will be considered as the current. That will be considered as the current. I hope you got to know. Okay, electrons are moving like this way. So I'm considering, suppose electrons. So electrons are moving like this. We have to take the current opposite to the electrons flow. Opposite to electrons flow. That is the direction of current. That is the direction of current. So I equal to Q by T. I equal to Q by T. I equal to Q by T. So I equal to delta Q by delta T. If you are taking rate, so with respect to time you can consider. So here you can consider as I equal to Q you can consider, that's fine. Then if you are taking the formula, so what is SI unit of current? Ampere, and SI unit of charge is coulomb, and SI unit of time is second. So 1 ampere equal to, so the 1 coulomb of charge flowing per unit time, flowing per unit time. So that is considered as the electric current. So that is nothing but I equal to Q by T. So 1 ampere equal to 1 coulomb per 1 second. So that we can consider. And next, so we can consider the drift velocity. What is the drift velocity? So normally you see inside of the conductor, you can consider this. Okay, so like a conductor you can consider. So in a little bit, so in a maximum. Okay, micro level is there, macro level is there. Micro level means in depth we are so considering. So like it is a micro level you can consider. So inside of the conductor, electrons are flowing. So here electrons are moving like this. So here the electrons are moving. Even you can connect this conductor to the battery. Then so the electrons start moving, right? The electrons are start moving. Suppose you can consider the electrons are moving in this way. So that is the path. Here I am concentrating only electrons row. So that is the reason the direction also we have to consider. Here you can take, I am considering this electron. Electron is moving like this. So there are so many electrons, not only one electron. So if you are one, automatically there is so much place because so many electrons are moving within the path. So within this path, the electrons are moving. So what happens? So if you are moving in a line, so besides of you also so many persons are moving. What happens? So when you are moving little bit faster way, or when you are moving, sometimes so you will hit someone like that, or some other person will come and fall on you. So you will fall on some other person like that. It will happen generally, right? Best example, while going to the college, so while going on the road, is it the busy crowd, then what happens? So you can see the traffic. So traffic, how it will be, so many cars will be, so many okay vehicles will be there, right? So sometimes when you are going, so sometimes so when it is moving in the same path, there are so many electrons are moving along the same path, or so many vehicles are moving along the same path. What happens? Sometimes one vehicle may hit the another vehicle, or backside vehicles will hit the front side vehicle, like this happens, right? So here also the same thing. So when the electrons are moving here, so this will hit the another electron like this. So because it's movement, it's moving, right? Those are moving. So in the inside of the conductor in the same path. So what happens? These electrons will hit one electron, and another electron will another electron. Sometimes it will hit the lattice or walls of the conductor also. Walls of the conductor. That time, so the average. So sometimes there will be collision will happen. Okay. So this electron will hit some other electron. This electron will hit another electron. This electron will hit another electron. Like that. So average will, the velocity will reduce. Again it will start. Reduce. Again it will start. Reduce. Again it will start. Like that. So sometimes it will hit the walls of the conductor also, like that. So what happens? So after collision, the velocity will be reduced. Again it will gains velocity. Again it will move forward, like that. So the average velocity of the an electron is known as drift velocity. Drift velocity. Why we are considering drift velocity? So after collision, so those all the electrons are moving in a particular directions, but the average velocity of the electrons is called drift velocity. Is called drift velocity. So you can consider I equal to n VDA. N VDA. This is a formula. So based on this one, problems also will come. We will see in the next class. So this is the current. This is the current. So number of electrons. Okay. Number of electrons. Like free electrons also we can consider. Free electrons. So here electron is nothing but 1.6 into 10 power minus 19. So coulomb. So this is the area of the cross section of the conductor. Area of the cross section of the conductor. Like this we can consider. So this is the drift velocity. So that is nothing but Vd equal to I by NEA. I by NEA. So this is the formula of drift velocity. So like the next one, Ohm's law. So what is Ohm's law? Normally you take a resistor like this, we can consider this resistor. So here it is positive terminal, negative terminal, battery is connected. Here is a resistor, you can consider current is flowing inside of the wire. Along this wire, current is flowing like this. I you can consider. So when the current is flowing, okay, when the current is flowing through a resistor like this, so the potential difference across the resistor is directly proportional to current flowing through that. V equal to IR. So R is a proportionality constant, that is resistance. That is resistance. So we can consider the formula also, we can take like this. V equal to IR, I equal to V by I equal to V by R, or like this we can now take. So the formula is like this. The graph you can consider. So I current on x-axis, potential difference on y-axis. If you take the graph between VI graph is a straight line, is a straight line. So when you can consider this, the substances, the conductors which follows the Ohm's law is known as ohmic conductors. Ohmic conductors we can consider ohmic conductors. Understood? So this is about the Ohm's law. Understood? So first point is electric current, next one is the drift velocity, and third one is Ohm's law. Thank you.